And I think we're live. Looks like it. Okay. Hello Internet. Welcome. Today we are going to do another day in Advent of Code. Let's just open up our trusty browser and go to Advent of Code and let's read the problem at hand and try to solve it. Hopefully today I will be doing this in Rust and will not be frustrated and doing it in Python like yesterday, which I took a day off on the easiest day so far. So with my luck, this is going to be a hard problem and I will try to do it in Rust anyway. Okay, your all expenses paid trip turns out to be a one-way 5 minutes ride to the airship, to an airship. At least it's a cool airship. Interesting. It drops you off at the edge of a vast desert and descends back to Island. Did you bring the parts? You turn around to see an elf completely covered in white clothing, wearing goggles, riding a large camel. Did you bring the parts? She asks again. Louder this time, you aren't sure what parts she's looking for. You're here to figure out why the sand stopped. The parts for the sand. Yes, come with me. I'll show you. She beckons you onto the camel. After riding a bit across the sand of a desert island, you can see what look like very large rocks covering half of the horizon. The elf explains that the rocks are all along the part of desert island that is directly above Island, directly above, um, making it hard to even get there. Normally, they use big machines to move the rocks and filter the sand, but the machines have broken down because the desert island recently stopped receiving the parts they need to fix the machines. You've already assumed that it will be your job to figure out why the part stopped. When she asks you if you can help. You agree automatically. Because the journey will take a few days, she offers to teach you the game Camel Cards. Camel Cards is sort of similar to poker, except it's designed to be easier to play while riding a camel. In Camel Cards, you get a list of hands, and your goal is to order them based on the strength of each hand. Hand consists of 5 cards labeled with one of ace, king, queen, jack, 10, 9 through 2. Interesting. The relative strength of each card follows this order, where A is the highest and 2 is the lowest. Um, every hand is exactly one type from strongest to weakest. They are 5 of a king, where all 5 cards have some label 5 of a kind. Sorry, 5 of a kind. Yeah. Okay. So labeled triple. Yeah, like 5 A's, 4 of a kind. Okay. Um, full house, 3 cards. Yeah. Okay. 3 of a kind. So 3 and some non-matching pairs. 2 pair and 1 pair and a high card. Okay. So basically like poker. Hands are primarily ordered by based on type. For example, every full house is stronger than 3 of a kind. Okay. If 2 hands have the same type, the second ordering rule takes effect. Start by comparing the first card in each hand. These cards are different. The hand with the stronger first card is considered stronger. If the first card in each hand have the same label, however, they move on to consider the second card in each hand. But let's just reread that paragraph again. Okay, if 2 hands have the same type, then we take a second order rule in effect. Okay, and we compare the first card in each hand. Okay, so basically, yeah, okay, so our ordering is not actually within like the types. We just look at the first card here against the first card here. Okay, so both are 4 of a kind, but 3 has is stronger because the first card is stronger. Okay, similarly, 7. Okay, so basically in the case of a full house, both are full house, but 7, 7, 8, 8, 8 is stronger because of the third card is stronger. Okay, so we do a lexicographical sort, basically. Lexicographical compare or string comp. Okay, so to play camel cards, you are given a list of hands and their corresponding bid. Okay, this is our puzzle input. So we've got hands and some magic score. And in this example shows 5 hands, each hand followed by its bid amount. Each hand wins an amount equal to the bid multiplied by its rank. Okay, so we've got more terms to compute and like keep track of. That's all right. So okay. Sorry about that. Okay, so we've got the rank where the weakest hand gets rank 1, the second weakest gets rank 2, so on up to the strongest hand. Because there are 5 hands in this example, the strongest hand will have a rank of 5, and its bid will be multiplied by 5. So the first step is to put out the hands in the order of strength. Okay, so 3-2 TK is only 1 pair. So only all other hands, the other hands are all stronger. So it gets a type, a rank 1. Okay, so basically this is a sort with like our special algorithm, which gives us like first the type of the card and then the actual values of the strings. Okay. By the way, I'm not sure. Let's actually look at that. Are these ordered? No, they're not ordered in a very nice way. They're not ordered like in a lexicographical comparison. We'd need to convert them into like an actual integer in order to compare them correctly. Okay, so yeah, basically we do a sort. Now you can determine the total winnings of this set of hands by adding up the result of multiplying each hand's bid with its rank. Total winnings. Wait, what? But these hands are not competing against anything. We're just ordering things. Okay, so this is not like we're still not playing the game. We're just looking at the hands and we are multiplying the bid by the rank. Okay, so we need to sort basically. So let's sort then. Let's open up Rust Rover. Rust Rover. We'll give it a go. This doesn't seem to be too terribly hard, but these sound like also famous last words. So we are on day 7. If you want to see day 6, it's not on the Rust side, it's on the Python side. So we've got not a Python package, but a Rust file. Oh, actually, you know what? Let's literally copy this one. Let's call that day 7. Update our enums, so we'll have the CLI working. And in our main file, we do need to duplicate that as well. Put that here, day 5. And we do need to import day 7. Is that it? I think that's it. Okay, let's move on to actually doing day 7. So firstly, we should clear out all of these. And we can remove all of the structs. We just want to leave like the most basic test. So everything except for like test part 1. And here we actually delete that, insert our own puzzle input, which is very, not our own yet, but the test puzzle input. And we do know what our result is. And this is definitely going to fail. We do not know yet what part 2 looks like, but we are definitely going to test that out in a minute. So let's just duplicate our test, and part 2 is going to assert against part 2. And for now, this is going to be an empty string, and that would give us like a quiet test until we are actually doing it. We can probably also like literally skip it. Probably there's a way to do that in the Rust side. And we do need to pass the actual cards and the winnings. So let's start with that. And once that's done, we could do all the other stuff. So first of all, separating things by spaces is not our thing today. We just want to map these 5 letters into some kind of card with some kind of way to order it. And we do want to extract also the bid. So let's write out how would we actually want to do that. So we would want a struct that has a card, and our card is going to have, first of all, or actually that's a hand. And we do have a card that's not a vector, that's actually going to be literally a tuple. So that's going to be a tuple of, we do have a type, let's just call that, U8 is enough for our type today. So that's going to be our card, that's going to be a U8. And we have card 5 times. That's very nice of Copilot to understand what I'm talking about. And the need for us to, we do want our hand type, and that is going to be, well, an enum. And an enum is, we do want like to derive a partial ordering on that. So ord and all of that things, yeah, seems to be good. And hand type is going to be 5 of a kind, straight. That's going to be 4 of a kind, full house, 2 pair, and is there 1 pair? 1 pair and high card. Yeah, so 1 pair, high card. Okay, so these are our hand types, and we need them to be. Can we literally assign them? Yeah, we can. Okay, so these are going to be sorted. We can sort by their actual value. So let's do that by actually inverting this thing. And now this is going to be 0, 1, 2, 3, 4, 5. Okay, so now they're ordered by actual value. And that means, yeah, and it says hand type needs to be hand type. That's okay. And we want also to derive ordering and partial ordering and equality. So now we can actually sort by the value here. So we just need to construct these hands. Oh, and we also want our bid, which is going to be a well, an I size. What? Actually, not. You know what? No. U32 is enough for now. Okay, so I think we've got all we need, like in terms of types, containers. Let's actually start passing. So pass hands. That is going to take a string, and this is going to be a separated list by, well, new lines. So that's going to be our new line. Right, separate list gets the separator first. Okay, and we pass a U64. So we don't need a U64 here. We can just manage with our U32. Yeah, U32 seems to be should be fine. And this is going to return us, give us, well, a vec. Oh, no, sorry. This is not a U32 yet. This is pass hand. So hand, it's a separated list of new lines, and each one is, well, a single hand. So these are hands, and let's actually pass the hand itself. So hand is going to accept, again, a string, and it's going to be not a separated list, but actually, well, a tuple of what is it? Basically, we do want we want to map this into a card type. Or you know what? This is actually, let's think about how do we want to like map in this card. So we could literally, okay, interesting. That could be nice to like we need to map like out of like from we need to map the card value basically. We could actually do that the same way, but I'll think about it in a minute. So we've got our map, which is the 5 cards, which we will write in a minute, and we don't need to map that. These are already going to be all 5 cards, so this is not a tuple, but separated pair of 5 cards, tag face, and our bid. So our bid is going to actually just be the U32. We don't need to do anything fancy about that. And we need to apply that to the input. And in order for that to be okay, we do need to like map it out. So 5 cards is going to, we would need to map that into, well, this tuple. So let's actually have that as our cards type. So type cards. This is going to be a tuple of card. And that's going to be, well, we are going to return cards and a U32, and this is going to be a tuple that we're going to do more stuff with it with later. Or actually, you know what? This needs to return a full hand. So we do need to do like more mappings. So yeah, function 5 cards. Well, I don't know what Copilot has completed here, but we are definitely going to do that. First of all, cards, plural. Now, this is going to be, we do need like the mapping of like digit to card. So let's just do that. We've got a tuple of, well, 5 cards. These are alpha, that's correct. And that's going to be no tags, no spaces, no. Not preceded, literally just 5 alpha numerics. So this is a tuple. It says found because we have not mapped that yet. So let's map that. So this is the way to map. Then get our tuple and we say, oh, actually, this is the place where we actually want to maybe do that programmatically. I mean, actually we could. We can capture all this tuple in the closure, which is this one. And now we can apply this mapping to each card. So I think that is correct. Let's see. No, so this is actually going to be 15. And I think that's enough because, well, it just needs to be ordered. So we got T, J, K. Okay, that's very good. Okay, so we've got our card. Let card match this thing. Yeah, okay, so we've got that. But we could literally do that not in. Why is it doing that in like? Okay, never mind. So we have our tuple, and I want to map it. Can I map our tuple? Interesting. Apparently I cannot iterate over tuples. Or that's very, very interesting. I wouldn't think that is an issue. Rust tuple iterator. Iterate over tuple. It says tuple.iter. How to map over tuples. Macro rules. Oh, here's an overly clever macro solution. Oh, damn. That's not good. I mean, we could literally use that because this is maybe a good way to do that, but damn. So can we, instead of that, like make a list of things and then limit the amount of limit its length, basically? We could say not a separate list, but many one. Okay, so yeah, many one. Let's literally this thing. We pass it this thing, and we don't need to pass it anything else. This is now a vector of strings. Oh, actually, many one U8. That's going to be non-complete U8. Yeah. And here we've got. Oh, it's not U8 though. Not U8. Okay, so it needs to be alpha 1. Okay, and now we've got our vec of strings, which is a V, and we need to do something with it, which is to first of all assert this length is exactly 5. And then let's mute. Why is it mutable all the time? There's no mutability required here. And here we are mapping ace needs to be 15. It's the highest scoring one. We've got 10, jack, whatever. Yeah. And anything else is pass U8. We do have our num U8 thing here, which is the thing that we need to do. And here we've got, we can collect that into a tuple. I mean, can we collect that into a tuple though? So we have our cards right now. This is a vec of, well, card. We don't want to sort that at all. So that's just going to be literally cards 1 through 3. Yeah, okay. And that's enough, I think, to return cards. And it says that it's, well, what? Expected sir found refster. Why is that? First of all, fn sir to card. That's going to be our whole closure here. Can we actually extract that instead of like doing that ourselves? So extract method, or like, can we do that? we've got this, and we are trying to now extract that as a function, and we'll call that stir to card. Okay. We can pass it in. Stir to card needs to accept, well, not a stir. It's actually a vector of cards. So that's going to be vec of ref stir. And we are going to set that like so. And it says expected stir stir found ref stir. And why is that? So let cards assert length, that's okay. We need to borrow like that. Okay, so we can borrow now and everything should be fine. And this is also a borrow here. We definitely don't want to do that every time. Okay, so we've got 5 cards pulsing. Okay, that's more than enough. And here we've got map of this hand into, well, we need to map that into a hand, which means we also need to construct this thing. So let's actually construct the thing from this well, let's actually implement hand new. So import hand, and let's import new. We've got this thing, and let's compute our actual rank, our hand type. So how do you compute that easily? I mean, we could have like some kind of bit mask maybe. Actually, yeah, maybe saving this in a counter, that's like a very nice and compact, not a very compact, but somewhat compact way to do that. So we know we need 3 bits like into for each card to store everything. Or we could just literally use like the Rust collections and not over engineer that. So Rust hash counter instead of like, I mean, we could literally use the hash map, but I wanted to frequency count. Yeah, yes, please. Yeah, frequency count is the one that I want to actually have. So Rust frequency count hash map. So folding into a hash map with this thing. Okay, so into character map, that's very nice. Okay, I think this is a very nice thing to have, which is we are going to basically just insert into a character map, and this is going to give us our all of our counts for the card. So we've got a temporary counter for this, or we actually might keep the counter around, but we do have it now. And let's think about how do we want to implement like the hand type from this map. So we've got our map. Let's first of all so compute. Let's think about that. So we would have at most 5 way, like we have not a lot of distributions that we need to take care of basically, but we do not know which rank is everyone. But let's think about that. Oh, by the way, we do know with capacity. Our capacity is no more than 5. So let's call that a 4, and that's going to be like very compact, like in memory, and we might need to grow that in cases of like extreme divergence, where like all the cards are different. Okay, so we've got this thing. We've got a word. So instead of actually, okay, so we do have the cards. We might want to reference the word and then compute the cards later. Let's actually do that. That might be nicer instead of like doing a lot of string, like small string conversions, like every time. So instead of like these 5 cards, literally just many mn. Many mn. Okay, that's min 5, max 5, and alpha 1. Or you know what? Literally, we could do that like for exactly 1 card. So instead of doing this whole crazy thing, we can literally have this 1 card, but you know what? Let's just have alpha 1. For now, and we'll deal with the cards later. So we've got our hand, and our hand now has, well, the cards and the U32 thing. So we could construct everything from this thing. So we don't need this whole 5-hand parsing. We are not handling the solution yet. So parsing the hand, and we can. Why is it unhappy? Because this is a vector of, yeah, this is crazy. This is correct. So this is just going to be a vec of hands. That is correct. And why is it unhappy? This function takes 1 argument, but 2 arguments. Yeah, we haven't actually done the thing, which is our function is going to be literally and new. And if this is not compatible in terms of arguments, then we are going to need to fix the constructor. So I think that is it. Let's actually compute, let's initialize this correctly. So we've got, a vec of alpha 1s. So this is still a vec of Charles, or actually it's going to be a ref stir at this point. And we could try to borrow that instead of like actually, you know what, let's pass it in. So we've got our cards. First of all, let's assert length 5, like good practice. And let's, we've got our frequency map, so that's going to be let frequency map be just factors join, sure. Actually, because these are already chars, I mean, yeah, haven't asserted that, but we know that these are chars. Can we actually split that into chars literally and not like do this whole alpha thing? That might be actually useful. So let's go for this area. And instead of many alpha 1, let's go with many char. That's going to be a non-complete thing, right? Making sure we are, yeah, okay. So many chars. So we've got exactly 5 chars. That is going to be a little bit cleaner now, that we don't need to do anything fancy around this area. That means we can literally do this insert into character map by giving it a ref of chars. A minute. So these are already chars. And then we don't need to do anything fancy here. We can just say chars.fold. And now maybe the gods of types would help us here, because I don't recall how to use. So this should be like a ref of. So char 5. Ooh, that's very nice. Interesting. We could assert this is an array of char 5 chars, or a reference to it. Okay, well, we could I'm down with that. If that compiles, this is amazing, and if not, then we need to do something about that. So let's just pass it in. We should be having a hash map from char to U32 at this point. U32 or I32? U, because we're plus one everything. So we could have that as a now from this frequency map, we can try to fold that into something useful, which is we could say something like values. Um, it there a way to iterate on these? It's already an iterator. So let's think about it. So we can collect them, or how can we sort that? Will not never be sorted, of course. We need to like collect that to something sorted, and then we can actually assert on the structure. So let's think about that. Interesting. Copilot is offering a different thing to handle this, which is if it's just matching on the length. If it's two, then a frequency map. Any values is four, then four of a kind, otherwise full house. Okay, I will take Copilot's assistance of that. That's like a very nice way to actually handle that. Let's literally assert that the frequency map, not length, but the sum, the values is exactly exactly 5. That is going to be very helpful in order for us to debug, and that we would know like everything has a valid value. And that is going to give us a hand type, which we can pass right here. Then our cards, which we do need to actually convert. Let's first of all, yeah, let cards be this thing, and would change all of that into card just so we'll have everything laid up very nicely. That way everything should be sorted now. And just to be sure, we could literally have everything just as a tuple and not as a struct, like not like a fancy struct. And that would give us a very strong like order guarantee that we are first going to respect the hand type and then the card types. Okay, moving on. So we've got our hand. Let's start testing everything. So we've got, first of all, let's actually test the character map. So test frequency map. I mean, this is just code we copy pasted off of the internet. So should be like testing it is somewhat useful. So we've got an assert equal into character map AAA. Okay, that seems to be okay. Let's try to run that and see if this is actually building. And it says that it's unhappy because of a lot of stuff. And it says char, expected char to be a function that returns result char, but it returns something else. Interesting. So it returns a function that returns, okay, so probably not that. So how do we, okay, so that should be either alpha 1 and then we need to do like a lot of like small we are splitting and joining like these 5 chars, which I'm very like I don't care about, like I don't care about them so much. I just want them to be separated somewhat neatly. So separated per. Oh, by the way, these are chars. This is not correct. Interesting. okay, we need to actually like map that into a card. So that's going to be star. Okay, so this is actually incorrect. So we need to do this. So this to do is very important. So let's go back to first like fixing up this thing, which was god damn it. Lost it. Okay, here we are. So we've got many alpha ones, and because I don't want them to be well, I want these to be kind of free, and not I want these to be Charles. So let's just do that thing where we pass that into char. So this is going to be our C. We are going to be so and C is a of type refster, and can say C Charles 0. So or you know what, Charles first. Can we literally get the first? We just want C. Oh, maybe C0. Maybe that's good enough. It says sir cannot be indexed with integer. Ooh, interesting. So okay, so I want as bytes. Ooh, that's the one. As bytes first. That's an optional U8. Can I say as Charles? As ASCII. None of these are like perfect, but as bytes first clone. Okay. Not amazing, not good. Let's try to remove the clone and see if everything breaks. Okay, so this seems to be somewhat okay. Let's try to compile that. And it says that method not implemented on this thing. Oh, we don't need the dot first anymore. Yeah, okay. And it says map. Method cannot be called due to unsatisfied trait bound. Okay, and it says map exists with opaque type function mute to result, blah, 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 blah. We're not satisfied. And it says that map cannot be called with thing. So let's go to this area and actually look at that. Oh, it's dot map, I see. So hand new, like that. Now we are seeing that this function is expected to take single two tuple argument, but it takes two distinct arguments. So instead of actually doing this, let's well split these into this thing and yeah, pass it in like that. And it says that it's U8 and not a SHA, and we can say no problem. Let's pass a U8. That's going to be a U8 array of size 5. And it says that not an iterator. So can we iterate on that like so? Iter in that way will be okay. And it says expected char found ref U8. And that's going to be a U8. And it says, well, the clone got vacuate. Okay, so let's vacuate that as well. I don't care about the fact that this being like exactly length 5. And it says now, oh, we need to first we need to borrow that definitely. And it says Borrow, yeah, borrow, sure. And it says to vec. So that's going to be a ref card. That's a ref thing. Found reference. To vec. Or no. Sum. Okay, sum. That's I'm okay with actually like telling it. This is a U32, and these ones are a vec of these A's would be bytes. Okay, that's very good. Next up, cloned. We don't need that. So first of all, expected equals this thing, which is a first of all, let hash map between the U8 and that's a byte. Interesting. So that might just be working now. It says that value of hash map U8 cannot be built from iterator over char integer. And that's correct. We need to have that as a byte. And it says that okay, so let's just build that out of line. So we've got let expected be this thing, which is a hash map between U8 and U32. Expected. And now we've got our expected and actual. And now it still complains about first of all, it says so let's just smash a vec call before that. And now we've got that maybe working. Oh, we can't say literally from iterable. Is that a thing, right? Can say hash map from iter vec 5b. Ooh. So okay, so our small frequency map thing is kind of working. Let's just have another test here, which is let expected be this, and that's going to still assert and be okay. Okay, very good. So we are building our dictionary correctly. Don't use that yet. Okay. This is tested. That's very nice. Let's pass the hand thing. So our hand thing, oh, but it still calls the constructor, which we haven't finished. So our hand type is going to be passed here, but we do have our to do here, which is to map the card. So we need to match this and then apply that everywhere. So char fn char to card. That's going to be a function that's first of all very inlineable. And that's going to take exactly one U8 and give us one card. And that's going to be 2 through 9. That's going to be exactly this thing, and otherwise 10 through 14. Okay. I think that's good. Yeah. Okay. So this is our char to card. And now we can apply that to all of these. So we've got this tuple, then hopefully the compiler will be able to see through all of this crap and actually optimize this, but I don't care. Okay, so we've got our parser now, I think. So let's test our hand parsing. So we can take this thing and let's test and parser. Function and test. move on. So input be not this thing. What? Okay, Copilot like decided to go on town on this. So our input is going to be this thing, and our assert equal is that. Yeah, hand on the input unwrap at place 1 should be. Is it a high card? No, it should be 2 pair. Just sorry, 1 pair. And we should be able to see 1, 3, 10, 3, 13. Seems reasonable. Let's look at that. It says that our assert is okay. We've got errors. Interesting. Alpha. So where's our alpha failing? So we've got these. This one's failing for some reason. Let's look at this. I mean, we could instead of like doing all of this crazy things, we could literally just pass that by hand and not with num. But I feel like doing things with num is like good practice. Okay, so map alpha1 c stir. Okay, so first of all, let's literally debug that. So c as bytes this thing. Can we actually see that before we are panicking? Nope, we are not seeing that. So we are panicking before that. Interesting. So alpha is panicking for some reason. A, B, C. Are we panicking before that? We do this. And wrap on error. So hand is receiving this thing and it's immediately applied. Oh, why is it? Okay, it's a separated pair with it's, let's just make sure. So it's first, second, first separator, then second. Okay, so this is a U32 and we are mapping this alpha thing and this is not good. So instead of doing that, think about it. Think about it. If we can have like a better thing here, which is not many U8, but actually, how do we map that nicely? What else is there in like the many multi-thing world? Or first of all, yeah, this is not important. We can do that. Complete multi-sequence. Okay, so sequence. Let's see what else do we have here in this sequence thing. We've got pair, preceded, terminated, separated pair, delimited, parse, um, what else do we have here? And a tuple. So that's not good enough. And in our multi thing, we've got a separated list. We've got our many 0, many 1, many mn, many count. Interesting. Many 1 count. What is that? That seems to be interesting. Runs the embedded parser, counting the result. What does that return? Oh, it's returning the amount of each one. We could say, okay, so that's not very good. Could be nicer, but probably like the worst way to like gather the hash map. So count is not for us. We've got fill, fold many. I mean, we could fold all of that and then have both the hand and both the hash map at the same time. So that might be a good way to do that instead of like doing that in the new function. Okay, actually, I like the fold strategy. So yeah, separated belt. So we've got fold many mn, which is 5 and 5. By the way, is it okay if minimum larger than 5? Okay, and then it says for count and 0 through max. Where's the assertion on the minimum? Okay, so if count is smaller than the minimum. Okay, so seems to be okay. By the way, what is the actual error here that we've got? Oh, it. Need to dock that back. Dock. Thank you. Our error says code alpha and input this thing, but it doesn't say our actual. I don't know if that came from like from which branch did it came from? Did it come from this branch or from this branch? Infinite loop check. Like I'm worried about the infinite loop check. Anyhow, let's just fold many and look at that. Let's just do that. Okay, so we've got fold many mn. Then we've got alpha 1. And then we've got our vec new, and we do want, not vec new, but we want to initialize something, which is, we'll think about exactly what we initialize in a minute. So to do on this thing. And then we've got our mutable accumulator. This is going to be a ref stir of length 1. We need to do something with that. So we've got, we want to return 2 things here. So we want to return, well, a vector with capacity of 5. Yeah, that's okay. But also, we want to return a hash map with capacity of 4. Sure, whatever. And both of these are here. Now we've got our, well, mutable tuple of both of these. And we could do 2 things. First of all, in our vector, we are pushing, and in our sorry. So you know what? Just the vector. Let's keep the frequency count for later. So we got our vector with capacity of 0, with capacity of 5. And then our mutable thing is just going to be this thing, vector of ref strs. Instead of ref strings, we are going to say item as byte. No, we are going to do the whole match thing, right? Card to card already, because we can. We can say card to card as bytes. And why is it unhappy? Because this is not a hand. Well, this is a deck of cards, and a deck of cards doesn't need to be a ref deck of card. We don't need the frequency. Oh, we don't need to do this translation now. And just say this thing. One was supplied. Okay, interesting. We've got like syntax error somewhere. Okay, so we've got, let's just verify that. So we've got fold many with this thing and our closure and our initializer, which is just, let's just go with vec new and not something fancy. So vec new. And since it's wait, it says function takes 2 arguments, but one was supplied. Vector push doesn't take 2 arguments. That's the fold. Oh, yeah, okay. Closing parens, basically. Okay, so we've got this thing. By the way, this could also be done the same with map, right? So many mn alpha, and that's the same, I think. Yeah, because this is collecting that into a vector. Okay, so same thing, but like with doing like applying the function later. Okay, so here we've got the deck of cards. We are just passing it in. Okay. And this one is panicking on alpha still. Interesting. So why is this happening? Let's just go with many 0. So we'll see if that's the the error case, and that's not the error case. So we are interesting. So code tag now. So our input is this thing, and we are using on the tag. So we've got max 5, or is it supposed to be max 6? See what now? Separate tag base. Input. Let's just go with many 1 just to be like very, very, very strict about everything. So it will just be okay, and it says code alpha. Okay, so alpha 1 isn't matching against 3. Oh, it's supposed to be alphanumeric. I'm so stupid. Okay, well, this has been a waste of time. Okay, and that is now panicking on assertions, which is the greatest thing to assert on. Okay, that's very good. So first of all, many 1 alphanumerics, and we are matching and already mapping that into oh no, we are not. Okay, so that should have been not a deck of cards yet. Should have been third to card, to card, card to card. And that is now going to be a whole lot better. And let's actually go to our session and see what plain things would be. It says assertion left equals 1, right equals 5. On what? Okay, so first of all, hand derives from everything. It says hand type. So, oh, interesting. So cards length 1. Why is that? Let's actually debug this assertion. So we've got many 1, so that's going to be now exactly many mn, and that's going to be 5 5 alphanumeric. This type alias is unused for now, and imports or whatever. And it says alphanumeric on. Interesting. So it doesn't understand where to stop. Why is that? Code alphanumeric. It shouldn't be alphanumeric. So back to this thing. So we've got this thing. This should be Or for some reason, or here because everything is like zero terminate. It's all terminated incorrectly. So still alphanumeric, and what the fuck? Separated pair. So alphanumeric 1. Wait, is that the recognize 0 or more? Recognize 1 or more ASCII numerical. Alphanumeric parser. So no, but I think that's exactly the one to use, right? You're supposed like to. Yeah, this is the one. So why is it unhappy? Any mn x exactly 5 and minimum exactly 5. And that is now running, and it's erroring out on alphanumeric here. So let's look at the internal call of this area. So Rust begin and white, that's not interesting. Okay, that's not interesting at all. How can we keep that sane? So this should start correctly. So what are we doing wrong? By the way, can we literally just map over the alphanumeric thing? That's going to work? No. It says, yeah, this is not thing. Many mn, okay, that's actually why. Okay, if we say 0, now it's still okay, so it's like stopping at some point, I don't know when. Minimum 1. Minimum 2. Now it says code alphanumeric error. What the hell? So annoying. Why is this like the thing I'm wasting time on? This is so annoying. Okay, so how would we do that another way? Because apparently I can't write anything. I can't write this today for some reason. We've got take 5, please. Just take 5. Then can map that into a stir where we say bytes map to card. Oh, thank you very much. Please just work. It says, is it from bits complete? Is that the one, the correct one? No, it's probably okay. Complete. We got character complete. So take. No, not from here. So other places to import take from. Take from nom bytes complete. It says to usize. Why do we need to usize? On what? It says Oh, 5 size. Okay, okay, here we go. So we did the thing, which is just literally take 5. Um, okay, so our hand parsing is not working. Let's test parsing multiple hands. So test hands parser. And let's just paste our own string here, and now we should have well, a deck of these 2 hands. Let's run that, and it says mismatch types, and let's look at that a little bit more closely. Got hands. This is a vec of, first of all, hands. Okay, so our hands parser is also working. That's very good. So our mapping is very nice, and we're done with that. Back to what was the question. So we are supposed to rank them now by something. So we need to sort, and then we need to basically multiply by their index, which is their rank, so-called. So we need to sort either ascending or descending, and that's it. So let's go to our run function. We got run, and first of all, let hands be hands on this thing. So fail to pass hands, that's okay. Then we are stuck with a vector of hands. And we want to sort that. So sort by so interesting. So we can sort exactly by just sort. Actually, you know what? Literally sort. By the way, is there like a sort thing that's not like mutable? I don't know. Let's just sort in place. So that's an immutable borrow. So mute hands sort. Then that's part 1. That's going to be iter dot enumerate dot is it fold? Literally just fold. So fold on we are summing everything. What is the so we are summing the product of the index and the bid. Okay, and that's a U32, and we are passing it in right now. And let's run the actual test, which is test part 1. And it says we've got different number, which means we need to actually figure this out. Or you know what? Let's reverse the sort, and then let's figure out if that is correct. Just before we do anything fancy. So we say hands dot reverse. Do we say? Can we say iter rev? Oh, iter rev. Very nice. And is that maybe like the thing? And it says this is too big now. Okay, so we actually need to debug. Oh, I see. First of all, oh, it's already I+1. Okay, Copilot has did like a bit of the work for us. And we are starting with 0, which is a totally reasonable number to start with. So we got hands iter. We don't know yet if we want to reverse or not. You know what? Let's literally debug our hands. So, oh, sorry, DG hands. And we do need to borrow that. And let's look at our hands now. So we are order. Okay, so first of all, this order is first of all 1 pair, and then is that correct? Let's see. So we've got 3, 2, 10, 3, 13. Okay, that's very good with some kind of bid. Then 2 pair. Wait, by the way, is this actually like this is not yielding anything, right? So I wonder if there's like a way to have that salted. So let's salted hands be salt. Ooh. Okay, so now we've got our salted hands. We don't need to think about like anything else. And that's still DBG, our salted hands. Very closely. Derive clone. Okay, sure. Let's derive clone. So our hand is going to derive copy clone. This field does not implement copy. Hand type. Copy. It says no iter bound on unit. Oh, interesting. So this is returning unit. This does not return the actual thing. So, so so hands clone. So yeah, let's whatever. Let's just give this. Let's just mutate the thing. Never mind. So hands salt. Oh, but we do need to make sure that we are actually salting the way we expect for things to be salted. So we do salt this. Now let's actually, yeah, okay. We should look at how this actually salts things, because we do have our hand type, which is high carb is the lowest and 5 of a kind is the highest. We can literally sort by key, so let's actually do that. So we do have sort by, and that's going to be not comp because this implementation is not implemented, not really. And our thing is going to be hand type and then cards. Comp this thing. Oh. And it says a lot of things. Don't show again, don't show again, leave me alone, all of these things. Move occurs here because hands have does not implement the copy trait. So yeah, we don't want to copy, we just want to borrow salt. And it says hands and then iter. Oh, I see, it's the debug statement, it's not anything else. So first of all, let thing be this, because apparently Rust wants that to be the case. We've got left, right. This looks the same, like the same result, which means that, oh, I see it's B compare A, and that's why it's the opposite of the previous one. So it should be probably A hand type and then cards. And the cards are a tuple of cards. Well, that's okay. How do we want to compare them? Yeah, just like a tuple, basically. So A comp B. This looks like the same salt, so I'm gonna trust on this thing that's okay. So where is our error right now? Let's look back on this thing, and it says one pair gets rank 1. Two pairs, so but one of them is stronger, so they get rank 2 and 3. One of them is stronger, so one of them gets 5 and 4. Okay, so the total winnings are going to be this thing times 1. So actually, let's literally just look at the thing. So we've got one pair time. So oh, by the way, we could literally okay. So let's attach the rank and then do the thing where we okay. So instead of folding, okay. So let's enumerate that. Okay, that should be also with the rank. So we've got our rank, which is, oh, I see, it's not very good. So let's collect that. It says need to collect that into something, which is a vector of don't care, but currently collect into a vec of type that's going to be usize and end. And it says that cannot be built from day 7 hand. Usize. It's a usize day 7 hand. Oh, because it's a reference. Interesting. So that's going to be a reference, and that might just work. Okay, so we've got our rank, which is rank 1 once we multiply things together. Then rank 2 is going to be 684. Is that correct? No, that's incorrect. Okay, so this comparison is okay. So this comparison is not working correctly. We've got KK against KT. So KT gets rank 2. What? Both two pairs. Is that correct? So we've got two pairs. So this is a 2 pair and this is a 2 pair. But they are ordered wrongly. And why is that? So we've got 2 pair and then 10 against 12. What? Okay, so this is definitely something here is incorrect. So this 2 pair thing is the, oh wait, this is the lowest rank, yeah? Right, okay. First of all, enumerate, let's just map that. I wanna +1 this, so we've got the rank correctly. Actually, you know what, that doesn't matter. Okay, never mind. I'm wasting time on the wrong things. Okay, so this one is the actual one. So 675 is actually getting the rank 1. Then these two, we should be seeing KK677 and BC677. Oh, wait, we are actually not seeing 677 at all. Where's our 677? It's the highest rank. Okay, this is definitely not sorting correctly. Okay, let's actually sort by ourselves. So we say sort by A, B, and then we say first of all hand types, but we need to compare that as well with other things. So let's do the tuple comparison by ourselves. We say tuple of B hand type. Can we like splat the B cards? thing, not the bid. So splat, and we like we say, okay, so let's literally go like that, comp all of that. And we don't need the thing and not this thing. We just want to close the prints. Okay, so we say big comp A, and why is that always big comp A and not the other way around? I don't know. So let's literally do that, and then comp ref all of this crap. Okay, so we've got everything, and pen type as U8. Seems okay. Yeah. Okay. Seems to be fine. Okay, so now that we've sorted everything correctly, it is still unhappy, but let's actually, okay, definitely not working. Is this just the like the initial order? 480 thing, 483. Okay, so we did shuffle things around, but it just didn't do it correctly. Wait, what? This is not a two pair. This is a okay, so Copilot was also wrong on the parsing, and I just didn't catch the bugs on this thing. So if its length, it has two things. Okay, so first of all, yeah, this is just not correct. Okay, so we need to actually fix this. Okay, so our hand type, if it's of length 1, we have exactly 5 of a kind. If it's of length 2, then we have either one of them is a 4, then we have 4 of a kind, otherwise it's a full house. No, that's also incorrect. So we can say um, 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 so let's just do this correctly. So we say let sorted values. That's going to be frequency map keys, not keys, values. Come on. Then first of all, mute sort. Okay, so we've got our sorted values. Now we can match on the structure of this thing. We can say match on let hand type match on equals match sorted values. And it says that match expression does not cover all possible cases. That's okay. So we say high card, one pair. Oh my god. Really does not know how to do this. Oh. Copilot is so stupid. Okay, this is correct. Everything else is junk. So we can say 4-1 is high type. Oh, it's probably in like sort dot. Oh, it won't work. Maybe let's reverse that. Or you know what? Let's just have we can say 1-4. So 2-3. That's a full house. We've got another. That's not. Okay, so we're missing 3 of a kind apparently. So we are missing full house, 3 of a kind, and that's going to be 3. 4, 5, 6. I'm not sure, but I'm just not sure, like, 3 of a kind anyhow. Then we've got 2 pairs, so that's the way to do 2 pairs. Then we've got 1 pair, which is, yeah, this thing, and high card, all 5s. Okay, so are there any more possible orderings? Let's see if this is okay. I think this is an actual like way to order things. So let's use this hand type, not whatever this crap it was. Okay, and let's first of all let's run all of the tests and see. Okay, expected slice, found vec. It says arbitrary expressions aren't allowed in patterns. So sorted value as slice that like compile. Okay, so test part 1 now works. Of course, everything works once we have like a nice algorithm that's actually like not written by Copilot. Amazing. So let's move on to part 2 then, right? I mean, let's actually run this algorithm obviously on the thing. But first of all, let's remove this debug statement. We've got this thing and everything is working, and we could even try to be cocky and try to sort just like that instead of all of this crap. And let's run this again. This should now sort. Yeah, okay, so everything's actually sorted. Okay, so let's run this over our own, not Python, no. Run AOC, we just need to edit that into being, where's the arguments? So we say D7. Apply, we just need to actually take our input. We take that in. We paste that into inputs. Clone D7. Paste everything in. Okay, so this doesn't seem to be very interesting. Seems like should quote unquote just work. Let's just make sure that this is actually like, yeah, okay, so let's run that. And we've got some input. Okay, that's a very big number. It might be wrapping around because of such, okay, so we got a gold star. That's very nice. Let's continue on to part 2. To make things a little more interesting, the elf introduces one additional rule. The J card are jokers. Wildcards that can act like whatever card would make the hand the strongest type possible. Balance this J card are now weakest are now the weakest individual card, weaker even than 2. The other cards can stay in the same order, AK Queen 10 through 9, and then J. Okay, J cards can pretend to be whatever card is best for the purpose of determining the hand type. For example, Queen JJ, Queen 2 is not considered 4 of a kind. However, for the purpose of breaking ties between 2 hands of the same type, J is always treated as J, not the card it's pretending to be. So JKKK2 is weaker than Queen, like 4 queens 2. Okay. So we need to order them and score them differently. That's like our the thing that we need to do. Now the above example goes very differently. 3 to 10 3K is still only 1 pair. It does not contain any jokers. So its strength doesn't increase. This one is only a 2-pill, making it the second weakest hand. T5-5 Joker 5 is now and KT JJT and QQJA are all 4 of a kind. And now they're ranked by their sorting thing, not by the thing. Okay, anyhow, we understand the rules. We need to rank things differently, and then do that. Okay, basically, okay, we understand the thing. I at least understand it. So we need to determine the hand type differently than the sorting type, and that's okay because we have built our things to be, well, kind of oblivious to that. So we need just another type of, we need to basically compute the hand type in 2 ways. So how would we do that now? Firstly, we could do this hand type calculation, not when creating the hand. We could literally store the hand as just a data structure without like doing the algorithmic things here. And that would mean that we could we can defer that into the sorting algorithm to the ranking later. So should we do that? Probably we should. Okay, so these sorted values and like the frequency map, all of that is like just not, we can move that out. Let's just build that. So we can say impl hand type fn part 1. That's going to accept not a self, but how do we construct? Okay, so this is not going to receive a self, but it's going to receive cards, which are, well, a tuple, 5 tuple card. Actually, that's going to be a Vekov card, just to be clean, and going to return a hand type. And we are definitely not going to let Copilot do this again. We know exactly what we want. This is our part 1 thing. That's going to return this hand type. And we can probably inline this, right? So yeah, we are just matching all the sorted values, and this is like the part 1 hand type thing. We will need to fix up the sorting algorithm. But firstly, before we do that, let's actually do part 2, which is, so fn part 2, going to set the same deck of cards and receive another hand type. And specifically, we want our J's. We will merge our J's with the top card, with the top stack. So let's just do that. So we've got our frequency map just the same. We are building it the same way, and we are going to, first of all, we don't need to mutate yet. We just want to say let jokers going to be the map pop j. We pop, by the way. So get unwrap all zeros. We want to mutably remove the map, so frequency map. Let's so just frequency map remove entry. So we are removing it. And now this assertion does not hold anymore, but we are going to mute sorted values. We are going to sort them, and we are going to, well, sorted values on 0 plus equals jokers. And that is it, I think. Yeah. Okay, so now we've got our sorted map and everything is the same. That means we can compute the 5 of a kind the same way now at this point. So this is now going to give us the same card type, but in a different way. We just need to compute it now for 2 things. So how do we do that? We'd say, well, first of all, we don't initialize this hand type anymore, not in this area. And this is okay. We can actually just store these as just the vector. We don't need to like structure that into a tuple. So let's just do that quickly. So we can say deck of card. I know vector is like not the right thing, but we could. I mean, I'm okay with that basically. So we've got that. We don't need anymore this destructuring thing. We can just say cards. And it says, well, we can literally pass that in. So that's going to work. It says the copy trait is not implemented for vec of cards. So clone it is. And it says new apply fix. Consider removing the borrow. Yeah, we are removing the borrow. Okay, move on. It says plus equals jokers, which is a ref of U32. And why is it a ref? Because we are getting this thing. So plus equals, and it says still, oh, a number. Just come on. It says, wait, is that, we need to unwrap that again? No, this is a number. Okay, so first of all, by the way, when we are removing this, are we getting the value back? Hub function, option V. Oh, that's nice. Okay, so we don't need to, okay, let jokers be this remove. So this is the pop, basically. And we are going to unwrap or 0. Okay, now we've got ownership on everything. And then it says plus equals cannot be applied to this thing. And we need to say something like get mute thing, and we can say probably, yeah, plus equals jokers. It says plus equals still cannot be applied to reference. Interesting. If that is a mutable reference, would that work? Or binary assignment operation cannot be applied to this thing. Index mute. Okay, good to know what the thing that they're using here is useful. So why the hell is it so hard to just do this? Got our frequency map. We don't even need to know like which type of things it's aimed for, and we just want to say not insert, but well, what? So why is this not like u32, and then it says plus equals cannot be applied to ref u32. So can I say mute on this thing? So index mute says method cannot be called with on mute ref2 due to unsatisfied trait bound. If we remove this thing, it is still unhappy. So what is this thing? What is this? Like u32 cannot be dereferenced, and then we can say, okay, interesting, apply fix. That says, oh my god. Okay, so this is grinding itself into like not a good spot. So then we can say, let's just add jokers to index 0. Index mute plus equals this thing, and then it says cannot be used, and then we are just unhappy. We say borrow, and that won't work as well because we cannot say add to this thing. And we need to like point things. I don't know. Borrow. We said remove, and then we are, and we also unwrapped on this. Okay, this is stupid. Rust vector increment and first item. Not every, no, every would mean iteration. Just want to say, okay, so iter mute, and then we are pointing to the one and just doing the thing. Don't store mutable the mutable iterator. Use it directly in the loop instead. That's okay, but how do I do this? No. I mean, I know that I could hack this by like doing the most terrible thing, which is like doing this. We can say iter mute self, then no, okay, enumerate, because I want the thing, and then we are mapping everything, and we are saying, well, no, just if not I plus jokers, otherwise then and this should be mutable v. Then we can say this thing, and it's still Interesting. So it says expected bool found give size. If I actually if I is 0, yeah. Then it says cannot be applied to type 232. Okay, so this is like something that I'm seriously not understanding. Is it this thing? Should I like borrow, or should I like unref this like once more? Okay. We could literally return v plus jokers, else v. And then we can say not even mute plus jokers. Ref. Then it could be just iterator, regular one. If I 0, then v plus jokers, else v. That's going to be let sorted values be, well, this thing. And then we can collect that back. We say, well, needs to be the same thing. Okay, so this is compiling, crazily enough. And we are getting a new number here. Is unsettling a little bit. But we haven't done the thing yet. Okay, so here we've got our sort, which we need to say sort by. Then we need to pass in the closure where we do this thing, and we say sort by not only the hand, but also with cards. So that's going to be the, well, not just A and B, but so AT equals and type BT, and then ata.conf btb, and that's going to be let and let, and that should return us to the same thing as before. Is it? Yeah, it is. Okay, very good. So our hand type for part 1 is now sorted and everything's fine. And now we can say same thing for our part 2, which is let this thing be the same thing. We just sort by part 2. Then we say let part 2 be this thing, and part 2, run that. That's passing, and we've got another number. Why is that? Because hand part 2 is not doing its thing that it's supposed to do. That what I'm reading from this thing. So first of all, this might be first. Okay, let's actually debug the frequency map. That seems to be a good thing to start with. So let's run part 2 right here. We will get like some kind of, oh shit, does not have this field. Ooh, right. So we don't care about this, and we need to convert this to vec. All of these things. And we've got some number, which is, well, we don't know if it's correct or not, but oh, actually we do. So this should be 5905. So let's paste that assertion right here, and let's start debugging. Because, well, we know this is, well, incorrect at this point, but hey Doel, nice to see you here. So glad of you to join. that you joined. I don't know. Have you done any pre-reading into the problem? We are basically sorting poker hands, but not exactly poker. And like now in the second part, we've got like a second rule, which is Jays are not jacks; they're jokers, and they are handling differently. Yeah, so basically we are handling now like now we should treat jokers differently than part two. So we are now debugging this thing, which is basically we needed to do something else with jokers, and once that's done, we will actually be able to do this thing. So PPG, we are going to clone that, and we are going to see what have we got here. And we see that jokers are always... Oh, and it's numbers, it's not J's. So J is not a thing. So instead of J, let's actually look at that. We are and look for 11s. So let's look out for 11s then. So we say 11. Say ref on that. And that should probably do a lot of the work for us. Once that's done, we see that we are... Well, let's look at that. We've got 11, and then we see two jokers. And then we should be popping them. We did... Okay, so this is popping these. Then we are seeing invalid hand. Ooh, because our assertion... Where's our assertion? Wait, what? Okay, so this assertion is not working, which means this one does not... Okay, interesting. So first of all, we are now popping the right key, which is good. And we now need to insert it correctly into the thing. So first of all, let's do one more clone here just to be sure, because I'm really not certain how should we do this correctly. But we do have our sorted values, which means they're now sorted like so, but we cannot use them yet because they're now without our hands. Oh, interesting. Okay, they are now without our jokers, so they could be summing up to anything from 0 to 5. And then we need to say, well, sorted values. First of all, okay, let's actually match on sorted values length. Interesting, because I know of like very like some interesting weak spots that we've got here. Okay, so this might fail just because, well, it might not have a length of like might not have index 1. It might be of length 0 at any point. So that like this this might fail. So first of all, if sorted values length is 0, then okay, you know what? Let's just actually let sorted values be match on sorted values length. Okay, and now it's going to be 0. That's going to be well, not a vec of zeros. No, why is it so stupid? Sorted values. If it's 0, then it's going to be a vec of jokers. Otherwise, that is going to... No, that's incorrect. That is just incorrect. This is going to be... Well, anything else going to be well, sorted values dot oh my god, why is Copilot being so stupid? This one says binary assignment cannot be applied. Panics may panic if index is out of bounds. That's okay. I'm okay with index out of bounds, but why don't you let me do that? Let mute. Oh shit! I see. It's a mutable. It's a reference of, and that's it. Okay. So basically, this should now just work. We don't need to do anything fancy. This should be, I think, we should be golden. Except for the fact that it won't compile, of course. So, vec u32 cannot be built from ref u32. And why is that? Because this one is a vec of refs, some hash map of references, frequency map. What's that? That's a u32. So it says values, and this is collect. So these are, can we clone them and that would just like do the thing? No. It's cloning the reference. That's not good. We want to clone the values. So values map into the thing and then collect into the vector. And let's just actually annotate the type here. Just cleaner a little bit to my taste. That's now a vec of u32s. And our logic should be working now. So interesting. We could also like actually not pop things instead of like popping and reconstructing them. So that might be the thing that might be useful. You know what? Yeah, good enough. I'm okay with that. So if now the tests are working, let's actually run that on our actual payload. And we've got a new number, which is suspiciously close to the previous number. That's not the right answer. It's too low. Okay, so where have I gone wrong? Okay, so firstly, let's have another assertion, which is assert equal sorted values sum u32 sums up to 5. And that is not failing. Okay, so this is not where we are failing. So we are still summing up to 5. Let's actually look at our sorted values. So we've got debug as a slice, sure, whatever. And let's debug that. Let's debug our map itself. So we've got our frequency map. Yeah, okay, so we are debugging our frequency map and we are debugging our thing. Let's not run the full payload, but the test part 2. So let's run that. And let's look at the actual things that we are seeing. So we've got frequency map 1431. And once we are looking at the sorted values, we should be seeing, okay, we are popping this and we have added that to the incorrect thing. Because of course, should have been the last one, not the first one. So let's literally reverse this thing. Well, not this thing. This is not reversed in the right area. So is that a thing? Can I get the last one instead of the The first one, I mean, we could literally, okay, so we need to append to the right one. I'm very surprised that, like, I believe they might have done that, like, intentionally. So this should be length -1. And why is it sorting again? There is no need to sort again. Just sort the values. So let's match on the length. Okay, so let length be this one, and then we can match on the length and use it also here. Okay, so our internal calls look way cleaner now. But I think they like literally did an adversarial example, which is amazing. I really like their like hostile approach to programmers. Oh shit, I forgot to turn off debug prints. Okay, but it's still finished. Um, and submit, and that's still not the right answer. Shit. So we've got our frequency map here. We don't have jacks here. Let's look for 11s. So you've got this thing, and this should map to 322. Um, let's look at that. So this one should map into, yeah, 3 of a kind. Okay, that's very good. Okay, so who's stronger, 2 pairs or 3 of a kind? Is that sorting correctly? So 3 of a kind is supposedly stronger than 2 pairs. Okay, that's okay. That means also that it's quite easy to just +1 the 3 of a kind instead of actually thinking about it hard and like trying to not just plus the greatest one. So let's actually increase the size a bit. So we've got 3 of a kind again, 3 of a kind again. Lots of 3 of a kinds. I want something interesting. Okay, so this one is like this would just increment any of these. I don't know. I don't care which is okay. So first of all, let's actually see. We obviously I'm surprised we don't have 11:5. Like no 5 jacks and all of that. Only 3 jacks? Not even that? What? Wow. Okay, so um 14 is an ace, yes. So like actually 2 to 14, yes, and Jack has now the power of 1, I think. With actually wait, let's just wait a minute. Oh, I see. Thank you very much. You actually saved me. I know where the bug is. The bug is right here. This should now map into a different value. This should now be mapping into a different thing. If we go back to the instructions, return to the page, it now says that jacks are now equal. They're the weakest card in terms of string sorting, and they are the blah blah. Where is that? Yeah, and they do like the magic thing basically. So we just need to have like two different sorting algorithms for the cards and for the hand type because of this thing. So instead of actually, okay, so we've got our chart to card. This is for part one. So we've got this thing is for part one. And let's actually, you know what? Okay, let's undo this rename. And I will literally edit the card values when we are doing the part two things because I'm too lazy for actually like plugging out this algorithm as well. So we've got this thing. This thing I think is working. We can actually remove these debug prints, which are quite verbose and chatty. And we are using this right here. And we could, instead of actually saving the cards in their, we could, okay, so we could save the Charles. Let's do that. Okay, so let's actually construct the hands correctly. So we've got cards, which should be a deck of Charles now. And that new call is going to be, well, a deck of cards, so we definitely don't want to do that yet. So this is just going to be bytes, so collect, and that's going to be a deck of child. No, that's not correct. That's going to be a deck of child. And now that's supposedly good, or maybe, you know what, U8s, because we do know U8s are like very predictable. So that's a deck of U8. So this one is now working as we expected to. So char to cards should work. So for part one, here we can say for each card, like we can compute the type. We could also compute the rank. So that's going to be so ranks. A rank, that's going to be a cards, sorry, a dot cards iter. Why is it unhappy with me? Are we in somewhere like fancy? No, I think this is okay. Let a and b a cards iter map. Come on, start to card. Collect to vec. It says that cards cannot be done with. Why is that? Okay. Okay, and now we can compare these two as well. So A hand, B hand. Okay. So this is now our part one and part two. So this is the thing here. And now we want to duplicate this function and just plug a different algorithm, which is just one, because one is now the weakest. I didn't understand the solution to the new jack sorting value issue you just discovered. Could you elaborate? So the jack should be now mapped into a lower value. So I'm just plugging the thing. I'm plugging the sorting, like the ranking algorithm later, basically. We could do that a little bit more in a cleaner fashion, but I'm like very, very lazy at this point of the night. So firstly, it is now angry at me, of course. Of course it is. Of course Why wouldn't why wouldn't you be angry? Okay, ref. Now it says this one also needs to accept a borrow. And everything now runs, and we've got, first of all, sanity check. Part 1 still answers correctly. Now, part 2. Submit. Too low. Shit. So part 2, let's look at that. We've got our hand. Ooh. Now, going back to the thing where we actually do the part 2 ranking right here. This is now the jack is now here. And we might want to assert that this is actually doing some work, but I mean, the fact that I'm actually having troubles here means that I'm not doing proper Rust, and I should have used enums, and then like I should have like mapped these into scores later. But you know, good for that. I'm knee deep and knee deep in this thing. Because you've guessed 4 times incorrectly on the puzzle, that's not the right answer. If you're stuck, make sure you're using the full input data. Please wait 5 minutes before trying again. Well, that's very nice. So let's look at this algorithm then. First of all, cards are already vectors. We don't need to do that. Can maybe borrow R2 and literally just borrow this vector. We don't need to do anything fancy. And that now is also, we don't need to do all this fancy copying. Okay, so we've got our hand types, we've got our mappings, and this one is now mapped into the right place. I hope. We've got our jack. We're mapping it in. That gives us a card, which is just a U8. You know what? Yeah, maybe we should use enums. But this is now, yeah, it's using, first of all, yeah, let's just a hand type, and then that's going to be the hand type. Let's reread this again. So 32TK is still the only one pair. Okay, so let's actually run this test again and start adding debug prints, and let's assert that everything looks somewhat sane. And first of all, okay, so we don't have our actual sanity test is not working. So let's tackle that. Apparently, Rust looks so hard. It is sometimes annoying. The compiler is very nice. And it has a steep learning curve, and sadly, it is a useful language, so I'm learning it basically. So let's actually sprinkle some debug prints and figure out what the fuck have I done wrong. So firstly, we've got this thing. Good. So this is hands sort by this thing, and then hands sort by another thing. So it's the same cards, we're just sorting differently. That's okay. And the fact that this one is iterated and then we're sorting it again, that doesn't really matter because we're mutating the hand twice, like the same hand vector twice. So that shouldn't be a problem. Here we're saying a cards iterate on, then we're mapping, collecting that back into a card. That's okay. A hand tap. I think like the hardest thing about Rust that it has a ton of syntax. Like so many things, like small things that actually have meaning, unlike things that are, very concise. Rust is very verbose and like it's types, basically. So we are sorting A and B. Let's actually print these out. This might be useful to print out. So let's and that should print out only the A hand. And okay, so let's also compare that to this thing and debug. Okay, so let's start comparing and see what's going on. Okay, so we've got two pairs, and indeed we have two pairs. Well, that's incorrect anymore because we actually have, we should have four of a kind, not three of, not two pairs. Oh, wait. Yeah, definitely not two of a kind. Okay, so hand type is incorrect now. So that means we need to debug here. So we've got the jokers. We should see the joker count. We should see our, let's actually debug our frequency map. So this is our frequency map just before we extract the jokers, and we should see our frequency map very much different after this thing. So let's look at that. This should be interesting. So this one is using the actual Charles now, and that's why it's not working because okay. Okay, so everything is now okay. Okay, I dislike the fact that they forced me into like sit in the corner and wait for 5 minutes. But let's run that now. And I forgot this thing again. This number looks suspiciously similar, which is very worrying. But I will try to. Yay! Okay, that's not very worrying. That's an actual different new number. Everything is correct. Okay, we are one gold star closer to restoring snow operations. That's very nice. Okay, so if we actually look at our solution, we basically had two partial sorting algorithms, not partial, but two sorting algorithms, where we both rank the card and like we rank the card differently each time. So we basically view it with two different algorithms. First one is just by the cards and pairs, and like the cards and like the type of the hand, which is like the plain poker type of hand. Then we added jokers, which means we replaced the jokers with we added the jokers to the most lucrative type to add it to, which is basically just adding it to the most frequent card, and that would always maximize the score. And we just needed to like mutate it correctly, and then we needed to plug this algorithm differently for each one. So we've got the part one hand type and the part one child to card ranking type, and then we've got the same algorithm here with part 2 the same sorting algorithm, but with the part 2 hand type and the part 2 part ranking algorithm. And that's it. I just want to remove these debug statements because they are terrible. And I think this is worth a commit and push to GitHub. Let's just run that. Are we still chatting around? We are not. Okay, that's very nice. That's very, very cool. Okay, cool. Thank you very much for joining, by the way. Really, I do appreciate this. And day 7 working. Commit and push. It says errors, and I don't care. Let's just push that. Okay. Have a great night, and I'll see you in the tomorrow, I guess. Bye for now.